Welcome to the channel. You really enjoyed the video about the Swedish turretless tank, so we decided to make another one. But this tank doesn't just lack a turret, it has two guns. Twice the absurdity, twice the failure. Meet the VT 1.2, a German tank that aimed with its entire hull and whose armor was not its main argument in battle. In January 1970, Germany and the United States ended the joint portion of the MBT-70 program, a collaborative project for a main battle tank that was supposed to become the best in the world. 10 years of development, 14 prototypes, nearly 1,100 million marks spent, and 0 tanks accepted into service. What went wrong? Everything. The hydropneumatic suspension, designed to allow the tank to kneel and crouch, proved to be temperamental and unreliable. The autoloader exploded at the slightest error. The Shillelagh anti-tank missile, intended to be fired from the main gun, flew anywhere but at the target. The Americans and the Germans couldn't agree on anything at all. The Germans wanted a 120mm smoothbore Rheinmetall gun, simple, reliable, and powerful. The Americans insisted on a 152mm gun launcher for the Shillelagh missiles, a complex, innovative system that didn't work. As a compromise, they put both systems on different prototypes. The program's cost skyrocketed. Metric versus inches, German standards versus American ones, the language barrier, competition between design teams instead of cooperation. By 1969, the cost of a single tank reached $1 million, 5 times more than planned. In January 1970, the program was closed. The Americans went off to develop the M1 Abrams, and the Germans developed the Leopard 2. But some people remained in Germany who decided, we can make a tank that's even worse. The concept was born from a simple idea. In a tank battle, the one who fires first wins. The probability of the first hit is the holy grail of tank building. Stabilizers, fire control systems, laser rangefinders. All of this is for one goal: to make the first shot hit the mark. Engineers sat down, looked at the statistics, and thought, the probability of hitting with one gun is, say, 60%. But what if we install 2 guns? 2 attempts? Mathematically, the probability of hitting with at least one shell increases. Simple logic. Kindergarten-level math. Brilliant. The Mackay Company received the contract. The program was codenamed Kampfpanzer III, Main Battle Tank No. 3. The lead engineer at MAK took on the project with enthusiasm. At first, the British joined the project for joint development. Apparently, the MBT-70 experience had taught no one anything. The Germans showed the concept: a turretless tank with 2 guns mounted on the sides of the hull. Aiming was done by turning the entire tank, like the Swedish STRV-103. The British generals looked at the blueprints, fell silent, glanced at each other, and then said very politely, "Guys, we want a normal tank with a turret and 1 gun that rotates. Thank you for the invitation, but we're out. Goodbye and good luck." The Germans were left alone. And it was for the best. No need to agree with anyone, no need to compromise. They could make the tank as insane as they wanted. The engineer began development. They took the chassis from the MBT-70. Fortunately, prototypes remained. The program was closed and the hardware was lying around uselessly. They shortened the hull, keeping 5 pairs of road wheels instead of 6. The weight dropped to 43.5 tons. The engine was the MT-UMB 803, a 12-cylinder diesel with a turbocharger. In normal mode, It produced 1,500 horsepower. With the afterburner engaged, it reached 2,400 horsepower. For a tank of this mass, this provided a power-to-weight ratio of 34 horsepower per ton in normal mode and 54 with the afterburner. For comparison, the Leopard 2, then under development, had 27 horsepower per ton. The VT was supposed to literally fly. The engineer promised the generals incredible mobility. The tank would be able to spin on the spot like a top and accelerate to 70 kilometers per hour in seconds. Reverse speed was also 70 kilometers per hour. It could rush backward as fast as it could move forward. Now, the main armament, 2 guns. But how do you place them in a turretless hull? The engineer figured it out. On the edges of the hull, the barrels face forward at a slight angle. The trajectories of the shells converge at a distance of 1,500 meters. The guns cannot rotate horizontally at all. All horizontal aiming is done by turning the tank's hull. The driver becomes a second gunner. He maneuvers the tank with the tracks to find the right angle. But they claim this wasn't a problem. The tank would be so fast and maneuverable that it could turn faster than the turret of a conventional tank. And thanks to the monstrous power of the engine, the turn would take fractions of a second. The engineer explained the concept to the generals with glowing eyes. A conventional tank must stop, aim, and fire, but the VT would fire on the move. The tank rushes at the enemy in a zigzag maneuver known as Vettelfahrt, like in a downhill ski slalom. The gunner locks onto the target in the fire control system. The tank twists left and right, and the guns fire automatically when the barrels pass through the aiming point. 2 guns, double the firepower, high speed, low silhouette. The enemy wouldn't have time to react before being covered by a barrage of shells from 2 barrels simultaneously. The generals nodded. On paper, it sounded convincing. The math seemed to work. The technology appeared feasible. The Leopard 2 was already being developed according to the traditional scheme. Turret, 1 gun, nothing innovative. But the VT could be a breakthrough. There was only one tiny detail that everyone tried not to think about. The concept assumed that the tank would fire on the move during a zigzag maneuver at a speed of 70 kilometers per hour with the precision to hit a moving target, using an automatic firing system at the exact right moment. In 1974, such electronics simply did not exist. Computers were the size of a refrigerator and 1,000 times weaker than a modern calculator, but the engineers insisted, "We can handle it, we'll develop it." In the autumn of 1974, the first prototype, VT 1.1, was ready for testing. A low, squat hull, 2 105mm L7 guns sticking out from the sides, no turret, a crew of 4, a driver, a commander, a gunner, and 2 loaders, 1 for each gun. The hull was made of ordinary structural steel, not armor steel, just structural steel, because this was an experimental platform to test the concept. Production vehicles would get real armor. Well, probably. The VT-1 was rolled out onto the proving grounds. Generals arrived to see the miracle of German engineering. They started the engine. 1,500 horsepower roared. Now the magic would begin. In the autumn of 1974, at the range near Kiel, testing of the VT 1.1 commenced. Ammunition for the 2 guns was fed manually, so there was plenty of work to go around. The engine roared. The tank lunged forward, 0 to 70 kilometers per hour in a few seconds. Reverse also 70. The generals smiled. That's mobility. Germans know how to build tanks. Now, the firing. They set up a practice target 1 kilometer away. The crew climbed into the tank. The driver took the levers. The commander and gunner took their places. The two loaders stood by the guns. All three were squeezed into a cramped combat compartment 2 meters long. The task was simple: aim at the target and fire. The driver began turning the tank. The tracks screeched. The 44-ton behemoth turned slowly on the spot. And right then, everyone realized the first problem. When the tank turns sharply, the crew inside is thrown from side to side. The driver, commander, gunner, and loaders were all tossed against the hull walls, onto the instruments, and into each other. The gunner tried to keep the target in the sight. Impossible. The reticle danced. The target jumped in the field of view. They stopped the tank and let the crew catch their breath. They aimed carefully. Good. Target in the sight. We fire both guns simultaneously. 2 shells fly out. Both miss. One to the left of the target, the other to the right. The generals looked at each other. What happened? The gunner reported. The target is 1 kilometer away, but the guns are zeroed for 1,500 meters. The shell trajectories hadn't converged yet. The engineers scratched their heads. Okay, let's try firing from 1 gun. Left gun, fire, hit. Excellent. Now the right gun, fire, hit as well. Good. But a general asked a question. Why have the second gun then, if you can only fire 1 at a time? The entire concept of double firepower required simultaneous firing from both barrels, and that only worked at a distance of exactly 1,500 meters. Closer or further, it was useless. They tried setting the target at 1,500 meters. They turned the tank, aimed, and fired both guns. Both shells hit. Hooray, the concept works. They put 2 targets side by side. Fire. Both destroyed. Double firepower in action. The generals perked up. This was it. But a tank officer asked, what if the targets are at different distances, 1 closer, 1 further? They tried it. Left target at 1 kilometer, right target at 2,000 meters. Firing from both guns simultaneously. Miss. The left target wasn't hit. The shell passed to its right. The right one missed too. The shell passed to its left. The guns converge only at 1,500 meters. The idea collapsed. 2 guns worked simultaneously only in one very narrow situation. 2 targets, both at a distance of exactly 1,500 meters, at the right angle to each other. In any other situation, you had to fire from 1 gun. They tested the main feature, firing on the move with automatic triggering. The tank drove in a zigzag. The gunner locked the target in the fire control system and held the trigger. The tank twisted left and right, but the guns remained silent. The system didn't trigger. The electronics couldn't cope with the vibration and speed. They tried firing manually while moving. The tank moved and twisted, and the crew was tossed around. The gunner tried to catch the moment when the barrel passed through the target. Fire. A miss by 10 meters. Another attempt. Miss. A third. Wide again. They engaged the engine's afterburner mode. 2,400 horsepower. The tank flew like a rocket. It spun with incredible speed. The crew inside turned into mush. The men were tossed around so violently they couldn't stay in their seats. The gunner couldn't see the side at all. Firing in such conditions was impossible. They returned to normal mode and tested the theory. In practice, either it turns fast and the crew can't work, or it turns slowly and the enemy has already driven away. They tried different tactics. Firing from a stationary position worked, but slowly. A conventional tank with a turret does it faster. Firing on the move didn't work at all. Double firepower only worked at one distance. They tested the hull. They brought out a DSHK heavy machine gun, 12.7 millimeter caliber, mounted on a tripod 300 meters away. Loaded with armor-piercing incendiary rounds, they fired a burst at the side of the VT-1. After the rounds, fresh marks remained on the hull. The sides clearly weren't meant to act as a shield. In this concept, the bet was on a low silhouette, strong frontal projection, and speed. Everything else was a compromise. This is the price of a turretless tank. They tested it with a 30mm autocannon. The shells left holes the size of a fist. They tried a 75mm gun. The hull was torn apart. The VT 1.1 was defenseless. The engineer explained, "This is an experimental platform. Production machines will get real armor." The engineers calculated that to protect the VT from 120mm shells, armor of at least 200mm was needed on the front and 80mm on the sides. This would add 20 tons to the mass. Total weight, 60 to 65 tons, the same as a Leopard 2. But the Leopard 2 is a normal tank with a turret that turns in any direction. The VT is a monster with two guns that only work under very specific conditions. Testing of the VT 1.1 lasted several months. Every time, new problems were found. Visibility was terrible. Sitting low, the crew saw poorly. The commander would try to peek out of the hatch, but he'd be blown away by the headwind at 70 kilometers per hour. Fuel consumption was insane. 2,500 horses eat diesel like crazy. The range was less than that of conventional tanks. The noise was unbearable. The engine roared just a couple of meters from the crew. Even with headsets, the men could barely hear commands. By the end of 1974, it was clear. The VT 1.1 had failed. But the engineer didn't give up. The problem, he said, was manual loading, small caliber, and insufficient automation. A second version was needed with autoloaders and 120mm guns. The generals agreed to give the project one last chance. In 1975, the VT 1.2 was ready. What changed compared to the first prototype? First, the armament. Instead of two 105mm L7 guns, they installed two 120mm smoothbore Rheinmetall L44 guns, the same ones being installed on the Leopard 2 then under development. Powerful, accurate, modern guns with excellent armor penetration. Second, autoloaders. A 6-round autoloader was only on the left gun. The right remained manually fed. The mechanism worked precisely. Fire. The clank of hydraulics, 5 seconds. A new 120mm shell is shoved into the breech, ready to fire. The crew was reduced to 3 people. The driver sat on the left, the commander on the right, and the gunner in the middle. All 3 were squeezed into the front of the hull. Loaders were no longer needed. The auto-loaders did their job. More space, fewer people to be tossed around during maneuvers. Third, the hull. The VT 1.2 received a slightly lengthened hull compared to the VT 1.1. 5 pairs of road wheels, just like the first prototype, and the same structural steel instead of armor. Fourth, the engine. The MT UMB 803 was pushed to the limit. In forced mode, it produced 2,400 horsepower, an incredible figure for a tank weighing about 43.5 tons, a power-to-weight ratio of 54 horsepower per ton. Cosmic figures. The VT 1.2 was rolled out to the range near Kiel. Externally, it looked even stranger than the first. two thick 120mm guns stuck out from the sides of the low, squat hull. The length of each barrel was 4.5 meters. The diameter of the barrel was 12 centimeters. The tank looked like a crab with two giant claws. Generals came to see version 2.0 of this miracle of German engineering. They started the engine. 2,500 horses roared. The tank took off like a race car. 0 to 70 in 11 seconds. Reverse also 70. The speed was impressive. The first firing tests began. The 120mm armor-piercing shells punched through practice targets, leaving neat holes the size of a dinner plate. The autoloaders worked like clockwork. The clank of the mechanism, hydraulics pushing the shell, 5 seconds, ready, reliable and fast. They tried firing at 2 targets simultaneously at 1,500 meters. The VT turned, aimed, simultaneous fire from both guns. Both targets hit. The generals perked up. This was it. Double firepower and automatic reloading. But the tank officer asked the same question. What if the targets are at different distances? They tried it. Left target at 1 kilometer, right at 2,000 meters. Simultaneous fire from both guns. Miss. The left target wasn't hit. The shell passed to the right. The right wasn't hit. The shell passed to the left. The guns converge at 1,500 meters. The same problem as the VT 1.1. The entire concept worked only in a very narrow situation. They tested the star feature of the autoloaders, continuous fire from both barrels. The gunner locked the target. Left gun, fire, the autoloader loads. Right gun, fire, the autoloader loads. 5 seconds passed. The left is ready again, fire, the right is loading. Another 5 seconds, the right is ready, fire. A tank-mounted machine gun made of 120mm shells. It sounded impressive. It looked effective. The practice target turned into a sieve in 20 seconds. The generals cheered, but in practice, this was completely useless. Because while the VT stands still and pummels a stationary target, a real enemy would have simply moved to cover or turned their turret and fired back. With a single hit to the unprotected hull, the VT would have been destroyed. They tested mobility in combat. The VT-1 flew across the range like a madman. 2,400 horsepower pushed the tank to incredible speeds. Turning on the spot was lightning fast. The tank spun like a top. But what use is that speed? While the tank is moving, it cannot fire. The guns are not stabilized. They shake with the hull. You have to stop, aim, and fire. And by the time you stop after accelerating to 70 kilometers per hour, the enemy has long since fired. They tried firing on the move. The gunner tried to capture the target in the sight. Impossible. The tank shook. The sight jumped. A miss by 10 meters. Another attempt, wide again. The automatic triggering system still couldn't handle the vibration. They conducted comparative tests with the Leopard 2, placing them side by side. The task: hit 3 targets at different distances. VT 1.2 versus Leopard 2. They started. The VT accelerates faster. 70 kilometers per hour versus 65 for the Leopard. The VT turns faster on the spot thanks to the monstrous engine power. The VT has 2 guns versus 1 for the Leopard. And that is where all the advantages end. The Leopard 2 fires on the move. An advanced stabilization system allows it to open fire at 60 kilometers per hour with high accuracy. The VT must stop before every shot. The Leopard 2 transfers fire between targets quickly. A turret turn in 3 seconds, new target locked, fire. The VT must turn the entire hull. Even with a powerful engine, this takes time, and the crew inside is tossed with every sharp maneuver. The Leopard 2 is protected by composite armor. The frontal projection withstands hits from 120mm shells. The VT is pierced by a heavy machine gun. One hit, and the crew is dead. The Leopard 2 has an excellent fire control system, laser rangefinder, and ballistic computer. The probability of a first hit is 90% at 2,000 meters. The VT, with its gun zeroed for 1,500 meters, can't even get close to that accuracy. The test result was obvious. The Leopard 2 won in all parameters except top speed, and speed without the ability to fire on the move is useless. They built 5 training vehicles called GVT, field test platforms, a mass production of mock-ups for field exercises. These were VT 1.2s, but without real guns. Instead of 120mm weapons, they installed mock-ups with Tilisi laser simulators. The system allowed for practice battles with laser shots and hit sensors on other vehicles. A 20mm autocannon on the roof created the imitation of a shot, a loud bang and gas discharge so the crew felt the recoil. All 5 GVTs were built between 1975 and 1976. They conducted large-scale exercises. The GVTs were sent into mock battle against conventional tanks with turrets. Scenario: breakthrough of defenses, urban combat, repelling a counterattack. The result was a total catastrophe. In open combat, the GVTs were helpless. The enemy attacks from the flanks. The GVT cannot turn fast enough. By the time the tank turns the hull, it has been hit several times. The crews complained, "We don't have time to react." In the city, it was even worse. Narrow streets, buildings, 90-degree turns. The GVT had to turn the entire hull for every turn or aim. By the time it turned, a mock enemy with a rocket launcher would have destroyed the tank 3 times over. Attempts to use the GVT as support tanks firing from long distances also failed. The enemy simply bypassed them from the flanks, and the GVT couldn't change position quickly due to its dimensions and the need for precise hull positioning. After the exercises, the crews reported the same thing. A conventional tank with a turret does everything the same, but better, faster, and more conveniently. 2 guns provide no advantages. By 1985, it was finally clear. The VT program was dead. The Leopard 2 had long since been adopted by the Bundeswehr and was showing excellent results in the troops. The VT provided not a single advantage that justified its complexity, cost, and fatal flaws. The program was officially closed. The VT 1.1 and VT 1.2 were sent to the Munster Tank Museum. The 5 GVTs were dismantled for parts, hundreds of millions of marks, 10 years of development, 7 built machines, and 0 tanks in service. Like the video if you think that sometimes a simple solution is better than a complex one. Subscribe to the channel to learn about other tank failures, and let us know in the comments which military hardware you'd like to hear about next.